Okay, everybody, in this video, this is a question paper from Eastern Cape, September 2014, physics paper 1, question 9. Okay, so get the paper and download it and just follow with me on question 9. So just follow. A learner wants to use a battery with an EMF of 13 volts. So they give us the EMF of 13 volts. Oh yes, before you go to the question, when you're doing electricity, don't forget to do your table. So we got series and parallel circuit, voltage and current. Voltage add up, current remains the same. Voltage parallel circuit remain the same, and the current adds up. And don't forget to do this. V total is equal to V external plus V internal. V total is equal to I total times R total. V external is equal to I external times R external. V internal is equal to I internal times R internal equal I total equal to I external equal to I internal. I total is equal to I R external plus R internal. You can go back to the introduction video to understand that table. Let's go. So we have the EMF. So immediately I'm going to put in my table the total voltage, EMF, 13 volts. Then they say the battery has an unknown internal resistance of R. So we don't know what small r. The walking doll has a resistance of 6 ohms. There's the 6 ohms. Okay. The learner uses a circuit to obtain the potential difference required for the walking doll to function. When the switch is closed, the reading on the voltmeter drops to 12 volts. And the working doll functions at a maximum power of 6 watts. So the power of this resistor is 6 watts. And they say that when the switch is closed, the voltmeter drops to 12 volts. So if you go from 13 volts to 12 volts, how many volts was lost? And that's why sometimes in physics they call lost volts. So this 12 volts is the reading on the voltmeter if the switch is closed. And that 12 volts reads the voltage going to the external circuit, therefore it's external voltage. Remember, in physics there is an internal circuit and an external circuit. So that 12 volts is going to the external circuit, therefore we call it external voltage. This 1 volt is called lost volts, but essentially that lost volts is actually the internal voltage. So immediately you put that into your table. So we got V external, which is 12 volts, and V internal, which is 1 volt. Put a smiley face there. Yay, we got it. Yay, we got it. And that's how they call it lost volts, because that's the volt that was lost. So the switch is closed, then the voltmeter reads the voltage in the external circuit. Now I also want to mention as a side note, if that switch was still open and they ask you what is the reading of the voltmeter if that switch was open. Now if that switch is open, there is no current here that's gonna flow to my external circuit because there's a break in the entire circuit. So then that voltmeter would have read the total volts, which is 13 volts. Then their answer would be 13 volts. If the voltmeter is if they say what is the reading of the voltmeter when the switch is open, but if the switch is closed, then the reading of the voltmeter is 12 volts, because then that voltmeter would read the external voltage. Righto. Now, I'm not going to go to the question yet. Now they give us power by the 6 ohms. So always remember that if they have two variables, just keep it in mind that power, remember, power formulae. Anyway, let's go to our first question. First question, 9.1. 9.1 says, explain briefly the reading on the voltmeter, why the reading on the voltmeter drops. I explained that because it's an internal circuit and there's internal resistance and there's loss volts. 9.2 calculate. So 9.2. So 9.1 is fine. 9.1 is fine. 9.2 says calculate small r, which is calculate the internal resistance of the battery and show all steps. So we have to calculate the internal resistance of the battery. Okay, but there's quite a lot that you're gonna have to do to calculate the internal resistance of the battery. Okay, so what do we got? Okay, so calculate the internal resistance of the battery. Okay, so this is a 9-mark question. Let's go for it. So you always take what you got. Okay, so if we're looking for the internal resistance, okay, so if you look at this point over here, for power we got 6 watts, right, and 6 ohms. So which means that we can actually calculate the voltage. We can actually calculate the voltage across the 6 ohms by using one of the formulae for power. Okay, but why are we gonna need it? I'm just thinking quickly. Okay, ohms, current. Okay, so current flows from the battery, right? It goes at this point over here. Current is gonna split into branch 1 and branch 2. So this is branch 1 and that's branch 2. Okay, or let's say the current, okay, let's say the current starts, okay, it doesn't actually matter, it doesn't matter where the current starts. So let's say the current starts here, and then at this point it goes to branch 1 and branch 2. So it's important to understand that this R is connected in parallel with the 6 ohms. Actually, it doesn't look like it, but you might just follow the branching. So it branches, and then that branch come together at this point, and then it goes again. Okay, so then it goes past the 2 ohms and then past the 1 ohm. So it's important to understand that this part over here is our RP. That is our parallel party. Okay, that essentially is our parallel party. Okay, and this parallel party, we can, if you condense it to one resistor, it will look like this. So let's say that's RP, which is connected to the 2 ohms, which is connected to the 1 ohm. You see that? So the parallel party is kind of connected in series with the 2 ohms and the 1 ohm. Okay, so I'm just trying to think quickly how we can calculate the internal resistance. So you can clearly see here that we got V total, we got V external, and we got V internal. So I'm gonna stop over here because it's a bit challenging to think it out, but I'm gonna give you the opportunity to try to think on how we can calculate the internal resistance, and then in the next video I'll then show you how we can get the internal resistance. Peace.